Hi guys, this is another lesson for CCNA course, and we will continue as second part of Implement Ethernet VLANs. This is lesson 9. If you remember, we discussed about trunking and what is trunking and how we can making a port as trunk for connecting between two VLANs in previous videos. But let me describe more about that. When your switch wants to send the packet to the another device, or for example to the another switch for sending the packet from the VLAN to the another VLAN, it put the tag on the frame that defines and clarify the VLAN ID, and the receiver switch will know the receiver VLAN's number, and we'll know that packet should be delivered to which VLAN. Okay. For trunking protocol, two protocols are famous: 802.1q and ISL trunking protocol. ISL means inter switch link, or and another one is 802.1q. Cisco created the ISL many years before 802.1q because the IEEE organization had not yet defined the VLAN trunking standard. And what about maybe you have a question, how many VLANs we can have in each switch? While both ISL and 802.1q tag each frame with the VLAN ID, the details differ. 802.1q inserts an extra 4-byte 802.1q VLAN header into the original frame's Ethernet header, as shown, for example, like this: tag VLAN ID. And 802.1q use only 12-bit VLAN ID field inside the header, and your switch can use 2 to the power of 12 VLANs. That means 4096 VLAN. But in the practice, it supports maximum of 4094 because the number of VLANs that supported is 0 to 4095, and practical is 4094 number of VLAN supported on 802.1q. Another item is switches supports the range of VLAN IDs into two range: normal range and extended range. All switches can use normal range VLANs with the values from 1 to 1005, and only some switches can use extended range VLANs with number of 1006 to 4094. But for supporting for extended range, it needs to configure VLAN trunking protocol, a special configure for VLAN trunking protocol VTP, we will describe later. Another important, I describe about that, describe for you, and after that going to the next slide. 802.1q also defines one special VLAN ID on each trunk as the native VLAN, defaulting to use VLAN 1. I said you in previous video, we have VLAN default that is VLAN number 1, and by default all ports of the switch connected to the default VLAN, which is VLAN number 1. By definition, 802.1q simply does not add an 802.1q header to frames in the native VLAN. When the switch on the other side of the trunk receives a frame that doesn't have any 802.1q header, it imagines and knows that the frame is the part of the native VLAN. There is another important, because of this behavior, both switches must agree on which VLAN is the native VLAN. For example, if you have two switches connected together, and in the switch number 1, VLAN 1 is native VLAN, it must be on switch number 2, VLAN 1 ISB native VLAN, ISB native VLAN as well, and so on in many switches connected. In previous video, we talked about configuring trunk ports for making connection between computers that reside in the same VLAN but in the separated switch, which was scenario number 1. Communicate computers in the same switch and the same VLAN. Maybe I have to making connection between some computers in the same VLAN and in the same switch. There is nothing I should do because all computers are in the same VLAN and can connection between each other. Scenario 2 was communicate computers in separated switch but in the same VLANs, like this image that you see. This is, we have SW1, SW2, some computers on SW1 assigned to VLAN 10 as well as SW2, and some computers assigned on SW1 assigned to VLAN 20 as well as SW2. In this scenario, in this situation, we need just one physical. This is I draw 2 ports. It is just logical. In real world, just need one physical port connect from one switch port to the another switch and another ports, and configure it as trunk port, and allow in the trunk configuration port for which VLAN allows to be packets can be passed through them. And when one computer in VLAN 10 on SW1 send the packet to the another side on SW2 VLAN 10 computers, it will pass and transfer through the trunk port and will receive to the another VLAN and destination system. We did it in previous video. Scenario 3 communicates between computers in same switch but in separated VLANs. That's a very important scenario. We will describe and work and practice in this video. But before that, it's need I describe a little for default gateway. What is default gateway? In real life, the door that allows you to communicate with the outside world from your local environment, known as default gateway. Imagine you are in the room. If you want going from your room to the another floor, you should pass and you should go through your room's door. It is your default gateway. If you want go from your room to the other building, you should go through door. If you want go to the another city, to the street, to the another country, in all of places, if you want to go and exit from your room, you should transfer, you should pass through the door. The door is the local environment gateway that you access to that, and you can use that for outside, for going out and going to the another place. That is the concept of default gateway. In the networking knowledge, the IP address of a device that your computer that connects to that for deliver data to that, because the device connected to other networks and can hand over to a destination, we know that as router. It is and it will be our system's default gateway. For example, I'm here, this computer, and we have the router, we have the switch layer 2 and the internet. The router connects to the internet, for example, by, for instance, wireless modem router, and router has another interface, another LAN interface facility 00 that connected to our switch, and my computer connected to another port of the switch. My IP address, my computer IP address is 10.0.0.1, and the router's facility 00 that connects to our switch is 10.0.0.10. Because my IP address and the router IP address are in the same range and easily without any other needed device. I can easily ping and communicate to that IP address. That IP address of the router that is in the same range of my IP address, it will be my default gateway. If I want send packet to any place of the world, into the internet, into any website, into any city, into any country, and so on, I should deliver my packet to my router's interface beside of my computer, and it will receive from my computer and will route to the destination. It means router, and it means default gateway in networking of LAN or WAN or any other networking maybe you perform and make. Look at this configuration. This is my computer's network interface card. I'm going to its configuration on TCP/IP version 4. At this point, I have default gateway. If you see exactly, my default gateway IP address is in the same range as my IP address, 192.168.10. This is class 3 or class C number of 192.168.10 range, and IP default gateway as same as my IP address range, 192.168.10. Just this is my host ID 110, and for example my router has number 1. Each device in the network, for example wireless modem, router, switches, computers, servers, all of computer based, all of IP based devices can be configured as default gateway, or you can configure default gateway in that interface cards. Okay, and what about Inter VLAN routing? Forwarding data between VLANs, same switch but separated VLANs. When we need routing between VLANs, this is the main question. If you created LAN or campus LAN that contains many VLANs, you typically still need all devices to be able to send data to all other devices, or some devices to some other devices. But what happens if our all switches are layer 2 switch? For example, imagine we have the building that has 5 floors. In each floor we did put layer 2 switch, Cisco 2960 model, and because the switch layer 2 forwards data based on layer 2 logic or MAC address, they don't understand and they don't know about IP address that can be separated and isolated some computers from each other, and beside that maybe need allowing connection between some computers, because if we create VLANs, we isolated systems into separated VLANs. Well, so if we need some computers in some VLANs can be connected to the another computers to another VLANs, for making this connection we need to know and understand IP address. Layer 2 switches don't understand IP address, just they work on MAC address. In this situation, we need another device called router. Imagine this is our network, a layer 2 switch, and some ports assigned to VLAN number 10 and some other points assigned to VLAN number 20, and all computers from in the same VLAN are connected, can be connected to each other and another VLAN as well. But we need making connection between VLANs. So maybe we need some computers in VLAN 10 can be connected to another computers in VLAN 20, but not for all. In that situation, we could put all computers in the same VLAN. Well, In this situation, we need another device called router. What we should do now, we put the, for example, Cisco router and connect that router by its fast Ethernet or gigabit Ethernet or fiber optic or any LAN interface to one of our layer 2 switch ports. I connected my router fast Ethernet 0/0 to one of my switch ports, and I can use router for making connection between two VLANs. But how we can do it and what issues maybe occurs? There is an issue. Imagine your building that has 5 floors, and on each floor maybe some layer 2 switches. Maybe you have, for example, 15 numbers of VLANs. VLAN 10, 20, 25, 22, and any numbers, you have 15 VLANs. Well, but your router doesn't have that interface that you can connect each interface to each VLAN. For example, you cannot have 15 network interface cards for fast Ethernet or for Ethernet interface that can connectable to each VLAN. But what we can do in this situation? The solution is this. I connect my routers by physical cable from router's fast Ethernet to one of switch port. Well, and now in this image, I have some, for example, 2 VLAN. Well, but divide this physical interface into 2 logical interface, like this, configuring trunking port in router, and divide this physical interface fast Ethernet 0/0 into 2 logical interface fast Ethernet 0/0.10 and fast Ethernet 0/0.20. .10 and .20 is same as the VLAN number. It is very, very important. Keep in mind your sub-interface that created on the router based on the router's physical interface name, your sub-interface number must be as same of your VLAN that resides to that. If you have VLAN number 15, your fast Ethernet sub-interface fast Ethernet 00 must be .15. Well, in this configuration, if we configure routing and configure trunking port on switch and router, when the packet will going to the router, will received by the sub-interface created on the router and will going out from the other sub-interface. In this scenario, in this example, I have fast Ethernet 00.10 with IP address 10.00.10 and another IP address that assigned to fast Ethernet 00.20 sub-interface with IP address 20.0.0.20. These 2 IP addresses assigned to the sub-interface logical interfaces to the router. So my IP address on my VLAN number 10, my IP address, for example, my computer IP address will be 10.0.0.2, and my gateway IP address is the router's IP address as same of my IP address range. My IP address is 10.0.0.2, router's same range IP address is 10.0.0.10, so it will be my default gateway in my computer. Like this. In VLAN 20, I have IP address 20.00.2 on my computer and default gateway 20.0020, which is IP address of my related sub-interface created on router. And router can receive data by its sub-interface and pass the data by its going sub-interface related to the destination VLAN. Well, and we reached out to lab manual. We want to creating VLANs, assigning ports and verify, defining trunk ports and verify, understanding default gateway concept, configuring Inter VLAN routing on Cisco router, and verifying Inter VLAN routing on Cisco router. Let's go to practice. Okay, this is Cisco Packet Tracer, and I want to design the network as exciting. I'm going to physical, and when you enter the physical, you will see like this, the home city, and you click on this point, and for example corporate office, we can put it here, and I click on this for enter to this building, and when I click on this building, we can see main wiring closet. If you cannot see there, you can add by this create new, for example, closet. Yes, with this one you can create new closet for making your physical networking. Well, I need like my network, I need one switch layer 2, some computers, and one routers for making routing between two VLANs. I need add one switch, select the switch and select switch 2960 model and drag and drop on the rack. Well, if I enter to that, I zoom in, you can see one switch added here, switch number 1. Well, I come back and I need some computers, for example, one computers and another computers, two computers. Click that. We have two computers on the table, and let me come back again and add router. For example, I can select this 2811 model router to the rack and enter that. Zoom in, we have switch layer 2 and router. Well, you can see your configuration in logical mode like this. For example, like this one, I put these two computers here and router on the switch. Well, but this is so real, such as real networks. Maybe you can see in some organization, in some networking rack, and so on. Let me go to the logical and we'll come back to physical again. Well, let me draw VLAN, for example, like this VLAN area, and name that VLAN 10 and VLAN 20. Well, and making connection, required connection, select connection and select a straight through cable, connect PC1 from fast Ethernet into port number 10 for VLAN 10, and connect another computer into switch port number fast Ethernet 0/20 for VLAN number 20, and another port for trunking port from I click on the router from fast Ethernet 00 of the router and connects to another open port, for example 24, fast Ethernet 0/24, but the router is turned off. We can turn on, zoom in, and from here you can turn on. If turned off and it's not configured, it doesn't have any configure, I will configure later. Well, and IP address, I want to setting IP address, for example, fast for sub interface of VLAN 10 on the router. I want to configure 10.0.0.10 and 20.0.0.20 for VLAN number 20. And this place is here, and the computer, going to computer configuration, desktop 10.0.0.1, an IP default gateway 10.0.0.10. The router's IP address, related IP address in the same range. And the other computer IP address will be 20.0.0.1 and default gateway 20.0.0.3. It's the same range IP address on the router. Well, let me create VLANs on the switch. This port is connected to VLAN 10 and this port is connected to VLAN 20. I'm going to VLAN switch configuration from the user mode by enable command, going to enable or privilege mode by configure terminal or conf space T, going to configure terminal, interface fast Ethernet 0/10, enter to the interface mode config, and switch port mode access, switch port access VLAN 10, creating VLAN 10. It doesn't exist, and exit, interface fast Ethernet 0/20, switch port mode access. What is switch port mode access? What's any other items here? For example, switch port mode dynamic. For example, switch port mode trunk. I will describe more later. Switch port mode access. I said you, if you want to assign the port into a special VLAN, you need change interface mode before that into access mode. Keep in mind, switch port mode access, switch port access, VLAN destination VLAN 20. It doesn't exist. We'll create, done. Okay, exit. And what we need now we need configure trunk port. Fast Ethernet 0/24. Interface fast Ethernet 0/24. Switch port mode trunk. Great. Close that. Look at physical. Some cables connected. If you see here, some cables connected from computers and one cable from routers. From router connected to one of the switch ports. Going to Cisco router. Its configuration area is very like as switch. Look at here, command line. It's asking us, would you like to enter the initial configuration dialog? I say no. I don't want to enter to wizard mode. No. Some enter, enable, configure terminal like switch, interface fast Ethernet 0/0. Well, if I would not setting IP address in physical interface, because if you remember, I described you, we need to divide the physical interface in two separated logical interface. For this reason, I cannot assign IP address to physical interface. In this situation, in this point, we should not assign any IP address to our router's physical interface. Just no shutdown. To be enabled in the router's interface and assign IP addresses to its sub-interface logical created and getting their connection from switch and PCs. So I entered into fast Ethernet 0/0, just no shutdown here. No shutdown, it will be up. Okay, change the state interface to up, change the state protocol, line protocol, change the state to up as well. Exit, interface, fast Ethernet 0/0.10. I have VLAN number 10, VLAN number 20. .10 IP address, it's entered to sub interface. You can see IP address 10.0.0.10 with subnet mask its default. Sorry, Before I forgot I didn't set encapsulation. Encapsulation .1Q VLAN number 10.1Q10. It points to VLAN number. Encapsulation .1Q10. Now I can assign IP address. Well, exit. Interface fast Ethernet 0/0.20. Encapsulation .1Q VLAN number 20. This is very important. This is very important. .1Q, after .1Q you should specify your VLAN's related number here, and IP address 20.0.0.20 with related subnet mask, and command end to ending command. I want to write to save configuration. WR is abbreviated of write for saving configuration, and going to switch and write as well. Show interfaces trunk. This show us fast Ethernet 0/24 is trunking port, but we didn't specify which VLANs can be sending packets through that. So I can go that again. Sorry, conf t interface fast Ethernet 0/24 switch port trunk allowed VLAN 10,20, and again show interfaces trunk VLAN allowed 10 and 20 number VLANs. Well, and show interfaces status will show us the interfaces status. VLAN 10 assigned to VLAN 10, assigned to VLAN 20, and fast Ethernet 0/24 is trunking port. Another useful command is show interface. For example, fast Ethernet 0/24 switch port, or fast Ethernet 0.10.0.20 switch port. It will show us the switch port status of that interface. Switch port enable, mode trunk, encapsulation .1Q, and trunking, negotiation of trunking is on. It means if another side of this port of switch, maybe for example another switch, and my switch interface status trunking negotiation is on. If the another side is trunking, because the negotiation is on, two switches can negotiate to each other, and my switch will learn trunking from the other side, and both sides will be in trunk mode. And default VLAN is VLAN number 1, and VLAN allowed trunking and enabled in allowed command is VLAN number 10 and 20, and it's okay. That's all. Let me check. Keep in mind, this is very important item. I say you troubleshoot or testing your communication step by step. This computer IP address 10.0.0.1 and its related IP address in the router 10.0.0.10. First ping this one, and then ping this one, and finally ping the computer in another VLAN. Look at here. Well, command prompt IP config. My IP address is 10.0.0.1 and gateway 10.0.0.10. So I can ping 10.0.0.10. It's okay. Replied from that IP address. Ping another side of the router. Ping another side of the router. Ping 20.0.0.20. It's okay. And now I can be I should be can ping successfully 20.0.0.1. I think this is 20001. Let me check. That's all, and all configuration correct and performed without any need for troubleshooting. Well, dear friends, this lesson is over. I hope the content is useful. Remember to practice in order to master. Over time, we will reach more advanced topics and lessons will become more interesting. Hope to see you in the next videos, and thank you for your subscribing, like, and comments. See you later.